Hi and welcome. We are at the Embedded World 26. My name is Andreas Willig. I'm the responsible product manager at TQ Embedded for the TI-based solutions. We have a fantastic demo together with Texas Instruments. So Thomas, please tell us about this.
What we show here is a predictive maintenance demo based on IEPE sensors. In principle, we are measuring vibration. The vibration is then transformed from the time domain into the frequency domain. And with the frequency domain, we can then detect very easily, based on the peaks, if there is an issue or if there's no issue.
Where we see our TQ boards and what tasks they have.
We are using the TQ module on two boards.
Yeah.
On one hand, this is on the edge gateway board, which you see over here, and you see it on the sensor board, which is over here. The sensor board takes up the vibration. We are then calculating here the FFT and then transfer this over single pair Ethernet towards the gateway board. On the gateway board, we are then visualizing the result, which you see here on the monitor.
Okay, Thomas, and what you are measuring there?
On one hand, we are measuring the time domain, then we are calculating the frequency domain. For example, on channel 2, you see a very good motor, which we now simulate with a sine wave. And you will see that there's one spike in the frequency domain. On channel 1, which is here at the top, you see a slightly damaged motor. So the sine wave is not exactly like a sine wave, and you see already like two spots over here. I have now a switch to emulate broken motor. And when the motor is broken, you immediately see this on one hand in the time domain because it's not a good sinus anymore. And you see that there's a lot of spikes in the frequency domain. So this gives an indication, the more spikes you see, the more damage the motor might be.
Okay.
But at the end, it depends a bit on the motor characteristics and what kind of curve you lay over the frequency spectrum.
A nice application. So what is the usage of this?
The main use case is predictive maintenance. We want to detect if a motor is getting damaged before it's actually getting damaged.
Okay.
So typically the motor, if it starts to get damaged, it will still run, but you may hear some noise or some vibration. And this is what we now measure with the vibration sensor. The more vibration suddenly occurs, the more spikes you're getting. And this is now giving an indication to the plant manufacturing that he needs to send someone to service the motor before it actually breaks down. Because the worst thing which could happen is that the motor blows up unexpectedly and even hurt people. So this is what you don't want. So it's better to send someone to service the motor before it actually happens.
Okay, that sounds super important, and thanks for your explanation.
You're welcome, Andreas.